So if the element is at the middle of the position, itself matches the key, then search is successful. So I am comparing here with the 17 is equals to key value 4. We have to look for the element 4. 4 is not equal to 7. So we have to repeat the process, and it is 4 is less than 7. The middle element, whatever you found out throughout the process, it does not match, is not matching with the key element. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our discussion with the topic searching. So in this session, we are going to discuss about the binary search. It is one of the technique as one of the algorithm is binary search. That is what we are going to discuss in this session. Let us start with the definition of binary search. So binary search, the key to be searched is compared with the elements in the middle of the sorted list. So what is the logic here? So here the key element, what we are looking for, what we have to search for in the given list is compared with the middle element of the sorted list. And here one of the condition for binary search is the list should be in sorted order, either in ascending or descending order, but it should be sorted. So we have to find out the middle element of the list, then we have to compare the middle element with the key element. Then if the two elements, the two values are matches, then the search is successful. See, that is the logic or algorithm of binary search. So if the element is at the middle of the position, itself matches the key, then search is successful. So in the given list, we have to find out the middle element, compare the middle element with the key element or the element to be searched for. If those two are equal or if it matches, then we have to say that search is successful. Then we have to come out of the program. If the element at the middle element position is greater than the key, means here the possibility is that the given element or the key element, it must be greater than the value at the middle element or maybe less than the value at the middle element. So in that way, if the element is position is greater than the key value, then the key is present in the first half of the list. Means we have to compare the element at the right side of the list or first half of the given list. So this second one, what is the next step? If the element is at the middle position is lesser than the key element, it means that the key might be present in the left half of the middle element or maybe at the second half. So if the element is at the middle position does not match with any of the element, then search is unsuccessful. So these are the different points to be followed in binary search or in binary search algorithm. So what is a binary search? It is a technique where the element, the middle element of the given list is compared with the key value or the key element. If those two are matches, then the search is successful. That is the end of the program. If the search element, the key element is greater than the value at the middle point, so then we have to search for the element at the first half or right side of the given list. Suppose if the element, key element is less than the value at the middle point, then we have to search in the second half or the value might be at the first half of the given list. If the key element does not match with the middle position at any point of time till the end of the list, then we have to say that search is unsuccessful. The element is not present in the given list. See, this is an algorithm or the steps involving in binary search. Let me explain with an example. So element is sorted in the num list along with the index value. So these are the elements. This is the elements of a given list. So 2, 3, 5, 7, 10, 11, 12, 17, and 19, 23, 29, 31, 37, 41, 43. These are the elements given the list, and this is in the first row we have index. So here last index is 14 and length of the given list is 15. So because index start with 0, so this is the last index and the length of the given list is 15. So here what is the first step here? First step you have to find out the middle element of the given list. Here what is the last index? So index n minus 1. So n is the size is 15. So minus 1 is 14. So we are noting with the variable last. Last indicates the last index of the given list, that is n minus 1. So first is a variable, or it indicates the first index of the given list. Obviously it will be 0. So first and last are the two variables we are using in this example. So now we have to find out the middle element. So how to find the middle element of the given list? The formula we are going to follow is here middle element mid is a variable equals first plus last divided by 2, and here all these of type integer data type. So here first and last index divided by 2. In this example 0 is the first index, last is the last index, 14 plus 0, that is 14, divided by 2. You will get the quotient as 7. 7 is the middle element in this example. So here 7 is the middle element of the given list. Next one is, suppose if the key value is greater than a value at the mid, means if the key element, means the element what we have to search for is greater than the value at the mid. So here index is middle value or middle element is at the index 7. So if the search value is greater than 7, then we have to search for the elements at the first of the given list on right side of the list. So in that case, then if that is the case, from here to here, you have to consider from this point to this point. Here the process it remains same. Again find the middle element from this, compare with the key value. If the element is matches, the search is successful in this example. So if you want to search in this example, right side of the given list, obviously last is this, then observe this, the first index or the variable first will be, it will shifted to this point. This will be this point, and how do we represent this? With mid plus 1. So middle element and plus 1, that is in this is a 8. 8 is the first for searching right side of the given list. Now if the key value is less than the value at the middle point, suppose I want to search for the value 5 here. So in this example 5 is less than 17. Now the process of searching will take place between the first of or left side of the middle element from this point to this point. In this case, so here the variable first index will be 0 as it is, but the last index it is not 14 because we have to search from this point. This will be at the last, that is here first equal to index 0, no changes in the first, and last index will be middle point minus 1, that is middle point minus 1, that is in this example 7. In this example 6. So the search process should start from index 0 till the index 6. See, this is the logic. In this list, we have to find out the middle element. Again, we have to start comparing with the key element. If the middle element is matching with the key value, then the search is successful. See, this is the process of binary search. See, that is what we have learned in the definition or the points in the slide here. So this is a definition. We have to look for, first one is the condition for binary search is list should be in sorted order or it should be a sorted list. Then if the element, I have to find the middle element, compare the key element with the middle element of the given list. If these two are matches, search is successful. Suppose if the key value is greater than the value at the middle point or middle position or the index middle index, we have to search at the right side of the list. Again, you have to start processing the same. Again, if the element is, the key element is less than the value at the middle point, then we have to search for the element from the left side of the given list. If the middle element in both the cases, in all the cases, if the middle element doesn't match with the key value what we are looking for, then we have to say that search is unsuccessful. The element is not present in the given list. So this is an algorithm definition for the binary search. Now let us start with example. So consider the given list. These are the given list. The same thing here, these are the values and these are the index positions, and this is the middle point. And how to find the middle point of this? First plus last divided by 2, as we have done in the previous slide. First is, in this example, what is first? 0. So 0 plus 14. 0 plus 14 divided by 2. If I say 0 plus 14 equals to 14, and it is 14 divided by 2. Here the quotient is 7. See, this is the formula what you are using in this example, 7. So 7 we are marking, this is the middle element 7. And here the element in sorted list along with their index value is this. And here I want to look for the value 17, or the key element is 17. So this is the procedure is same here as the first iteration. We are comparing the last iteration. What's the middle element of this? Here 0 is the first index, 14 is the last index. 0 plus 14, what we have done here, 7 is the middle element. Now I am comparing the 7 value at the index 7 is 17 is equal to 17. 17 is the key value. In this example, these value is going to match, these two matches, then it said that the key element is found at the search terminates. Means, or the key element is found out in the given list, then we have to terminate the search, or we have to stop searching for the element. Now in this example, the loop continues. It should be first index should be less than or equal to last index. So as long as the condition is true, loop continues. So in this example, so the element is found. This is the middle element, that is 17. At the middle value is 7. So we have to say that element is present at the index 7 or at the position 8. See, this is an example for binary search. Now look at one more example. So here element is found at the index 7. So we can print the message as element is present at the position 7 plus 1, that is equals to 8. See, this is the binary search. Now let us look at one more example here. Now let us search for one more value, that is key value 2 in the same example. So this is the given list. These are the values in the given list. Now we have to search for the value 2. So let us see the example now. Here first one is at the beginning, first value 0, last is 17. So 0 plus 14, that is equal to divide by 2, the quotient is 7. So middle element is 7. So in this example, middle element is, the index is 7. 17 is the middle element. So I'm comparing with 17 is key value is 2. 17 is equal to 2. No, in that case, 2 is less than 17. So we have to continue, or we have to go for next iteration. In the second iteration, if the key element is 2 is less than 17, we have to search from the beginning till the middle point or left of the given list. So in this example, we have to start searching. Now we have to observe this as I told you in the previous slide. So if it is in the left hand side less than this, first value will be index 0 and last value will be middle element minus 1. So we are following this logic. So accordingly, in this example, the 2 is less than 17. We have to search to the left of the given list. Accordingly, first element is 0, last element is, here middle element was 7, 7 minus 1 is the 6. Now we have to compare this, 0 plus 6, 6 divided by 2, quotient is 3. 3 is the middle element. 3 is the middle element. If you look at the index here, so here this is the middle element. So here the value is 7 is the middle element or the index 3 here. Now I am comparing 2 with the 7. We have to compare 2 with the 7. If 2 is not equal to 7, and again we have to find out is 2 is less than 7. If 2 is less than 7, again we have to find out or have to search for the element from the left half of it. So if you look at the example now, in this example 7, so this is not matching now. So we have to search as 2 is the given element 2 is less than 7. We have to search on left hand side. In that example, so left hand side, the index will be 0, first will always 0, and the last index will be, it was 3, now it comes to this point, that is 2. So here, please make a note of it. First index is 0 and second in last index will be 2. It is m minus 1. So it is 2. Now we have to compare this. 2 plus 0, 0 divided by 2. It is divided by 2. Quotient is 0. Now we have to find out the middle element, that is 0 plus 2, that is 2 divided by 2. Quotient is 1. This 1 will be our middle element. So next we have to search for 0, 2. As I say, middle element is 1. So element at the index 1 is 3. 3 is equal to 2. It is no. It is not. It is no. In that case, is 2 is less than 3? Yes. Means again we have to search for from the left side of the given list. So here 3 less than this, middle element is 1. So if you look at the example, so here at the element 1 is not matching. Next we have to search for this. In that case, first will be first always. There is no changes. And the last will be, what is the last? Last will be, it is 1 minus 1, that is 0. So here first will be 1. So and here it is 2 is less than 3. So index will be 2 minus 1, that is 1, or it was 1, 1 minus 1 is 0, 0 plus 0, 0. So we have to have a quotient is 0, and here quotient is 0, quotient is 0, and the element at the index 0. So if you look at the example, so here element at 0 is, the element at the index 0 is 2. So here this 2 is matching with our key element 2 in this example. So here is 2 is equal to 2, yes. So condition is true. Then we have to say that the element is found, key is found, and search terminates and returns position as mid plus 1. So this is once the element is, the key element is matching with the element at the particular index. So in this example 2 equal to, key element is found and we have to stop searching further, or we have to, that means we have to come out of this loop, or it is end of the program. Then we have to print the message at middle point plus 1. So in this example, so 2 is found at the index 0. So position is 1. We have to print the message. So element is present at the position 1 because it is at the index 0. So this is example for binary search. Now let us go for one more example, that is example 3. Let us consider one more example with the key value is 4. Now let us search for the element 4 in the given list. If you look at the list, here element is 4. I want to look for element 4 that is not present. Obviously search will be unsuccessful and we are supposed to print the message element 4 is not present in the given list. So let us start the process. These are the given elements along with their index. So first, you know that first and last at this stage middle element, this is the middle element, index 7, element is 7. Let us start the comparison. So in this one, you take this example now for the first iteration. So we are comparing first and last, first plus last divided by 2. We are getting 7 is the quotient. So element at the index 7 is 17. So I am comparing here whether 17 is equals to key value 4. We have to look for the element 4. If these two are not equal and the 4 is less than and the 4 is less than 17. If the 4 is less than 17, so we have to compare the elements from the left side of the middle element. So in this case, from 0 to index this. In the next example, so this is not equal from this part of it. So 0, 2, 3, 5, 7, 10 and 12. So we have to search between these elements. In this example, as we have learned, index first will be 0 always and the last index will be, that is m minus 1, that is 6. In this example, 6 is the last index. Now again we have to find the procedure, we have to start the procedure. Is 4 is equal to middle element of 7. So in this example, 0 and 6. 0 plus 6 equal to 6 divided by 2, quotient is 3. So in the example, quotient is 3, index 3, element is 7. In this example, this is a middle element. So is 7 is equals to 4. So in this example, 4 is not equal to 7. So, and again, the 4 is less than 7. If 4 is less than 7, again, we have to search the element between 0, 1, 2. In the next process, we have to repeat the same process. So in the next step, we are going to find out the middle element. So here, key value is 4. So here, middle element is 7. In this is 7. So here, this 4 is not equal to 7. So we have to repeat the process. And it is 4 is less than 7. So here, this 4 is less than 7. Now we have to compare, or the process should take place from here to this point. In that case, please make a note of it. These are the values here. Now, next index is 0 is the first index and last is the 2. It says, as per the formula, it is middle element minus 1. Here 3 minus 1 is 2. So, this is the first index, this is the last index. So, next we have to find out the middle element between these two values. So, here 0 plus 2 equal to 2 divided by 2, that is quotient is 1. So, in that way, quotient is 1. So, this will be the middle element. So, this is index. So, index at the 1 is 3. Now, compare is 4 is equals to 3 in this example. So, 4 is not equal to 3 again. But in this example, that 4 is greater than 3. We have to observe this. 4 is greater than 3, greater than the middle element. Then we have to search on right hand side between these two elements. Search should take place between these two elements. So accordingly, now if we observe this, last index will be as it is 2, here middle element plus 1. So if we observe this, in the next one, the process had repeat the process with these two elements. So accordingly, first index is 2. Here in the previous process, middle element was 1 plus 1, 2. So in this example, the first index will be 2 and last index will be as it is 2. That is 2. So in this example, how to find the middle element? It is 2 plus 2, 4. 4 divided by 2. Quotient is 2. So quotient is 2. In that way, quotient is 2, index is 2. This will be the middle element of the given list between these two elements. So here, so element 4, now the element at the middle element is 5. So I am comparing 4. Is 4 equals to middle element of index 2. Index 2 is 5. So 4 is not equals to 5. Again, these two doesn't match. So again, we cannot proceed further because this is end of the process. So we have to stop searching for the elements. So in this example, from the beginning till the end of the given list, so the element 4 is not matching with any of the element in the given list. So if that is the case, so element is not present in the given list. So finally, after this process, we have to print the message saying that not successful. So in this example, element 4 is not found or not present in the given list. So because by the middle element, whatever you found out throughout the process, it does not match, is not matching with the key element what we are searching for. So mid element is not matching with any of the key value till the end of the process. So till the end, it doesn't match with any of the key value. So we have to print the message element is not present or search is unsuccessful. Student, so far we have discussed about a binary search is a type of searching technique. Let us continue our discussion in my next session. Thank you so much.